everyone. We are going to talk about nuclear weapons safety, how it affects you, and what you should be doing about it. So, if you live in Iowa, hundreds of miles upwind, buried in the ground are nondescript slabs of concrete, essentially, that wouldn't look like much from a distance, but you better believe there is a very great significance to them. They are nuclear missile silos, holding a Minuteman III ICBM, currently with one 400 to 500 kiloton warhead on board. That is far more destructive than any weapon that's ever been used in history. For comparison, the original Trinity nuclear test and also the weapon that destroyed Nagasaki, that was 20 kilotons. So this is orders of magnitude larger. And other people have written in the past of concerns like, oh, what if there is an accidental nuclear war? Which is, I believe, a valid line of inquiry. Nuclear weapons are about us, essentially. They're not just this abstract geopolitical issue that could one day come raining down and end civilization, and we shouldn't be worried about it. No, I think they are a genuine and proper target of policy. However, there's also industrial accidents we have to think about. These are industrial systems. Industrial systems are by no means immune to accidents. In fact, it's almost the reverse. Accidents happen to industrial systems. It's just something that happens. So, what if there's a fire in a missile silo? What if the missile catches fire? What if the missile explodes and it blows the silo door off and it tosses the warhead several hundred yards? Or, the worst case scenario, it explodes. There is a full nuclear yield within the silo. So the material around the silo, the former concrete in the soil, is plasmized. It's sucked up into the vapor cloud. And that material is neutron activated. It's made radioactive by the intense neutron flux of the bomb going off. Later, this material is going to drift into a cloud that drifts eastward, i.e., towards us, and it's going to start producing fallout as the radioisotopic material falls out of the cloud, which is where we get the name. What this means is that it will start snowing, but the snow kills you. It's not a good day when fallout is coming your way. Now, most of this, at the distances involved, would be confined to Nebraska because these weapon sites are on the western edge themselves of Nebraska. And there would be daunting tasks in those communities, not only because of the horrific radiation dose that anybody standing outside would experience, but also because of that they are very rural and there might not be adequate emergency resources, and getting resources in might be very hard. But even here, I would think that people would panic. I think that there would be panic regarding, oh, is Iowa's corn safe to use? So we're going to talk about nuclear weapon safety and how we prevent accidental nuclear explosions. And again, really, how they affect you. So the answer kind of lies in design, permissive technologies, so the weapon only works when it is intended to function. It's an always never standard. It always must work when commanded to do so, and never otherwise. And also, we're also going to think about failure in complex systems. So the consequences if a nuclear weapon went off would just be abysmal. You have thermal effects, blast effects over a huge area, firestorms, and the radioactive fallout I talked about. So how do we prevent this? Well, there are several technologies we use just as a first line of defense. First are PALs. PALs have a friendly name because the Air Force didn't like the idea of putting locks on a weapon, but a PAL is what it sounds like. It's a lock. In fact, the first PALs were electromechanical coated locks, and the ultimate function of a PAL is that the weapon cannot operate unless you put in some sort of authorization code. And again, PAL made it sound friendly. It was an electromechanical coated lock in early weapons. We don't know what it's like in contemporary weapons, and I'm not going to speculate. I have heard the idea of encrypted firing parameters, which is interesting, but essentially no authoritative data has been released about this because it is a nuclear weapon arming system. You also have weak links. These are what Eric Schlosser in his 2013 book Command and Control talked about. A weak link is a component that fails in abnormal environments, such as a fire, so that the firing sequence can't operate. It's like the capacitor that normally would set the explosive lenses off fails if there's a fire. And as a counterpoint to that, there's strong links. Strong links are just what they sound like. They are strong components that keep out spurious signals until the weak link fails. And on top of that all, there's IHE, insensitive high explosive, which is designed to be much harder to set off than regular high explosive. Regular high explosive, if you burn it, it can eventually detonate. With IHE, that generally won't happen. Even if you shoot it with a high velocity bullet, it also might not go off. So, you know, how should we think about accidents? And one thing we can adopt is systems theory. In Herman Kahn's just eminent work on thermonuclear war, he uses systems theory to perform a variety of analyses, typically grounded in the context of a nuclear exchange between the US and the Soviet Union and other aspects of nuclear warfighting, but he does consider the reliability of the systems. Also, there's Scott D. Sagan's book, The Limits of Safety, which actually goes into formal what it's called is accidents theory on nuclear weapons, and he presents two counterposed paradigms. The first is normal accidents theory. Normal accidents theory holds that in complex systems, accidents are inevitable, i.e., normal, just because of how complex a system is. I am a fan of normal accidents theory. As a converse to this is high reliability theory. High reliability theory states that by designing a system appropriately, you can make it essentially reliable to a finite degree and make failure infinitesimally improbable. Um, so will we keep going on this winning streak that we've had for the past 80 years, where there's to public knowledge, never been an accidental nuclear explosion, even though there have been close calls? Well, the DoD and the National Nuclear Security Administration certainly think so. In fact, in Chapter 8 of the DoD Nuclear Matters Handbook, they again present the always never dichotomy. A nuclear weapon must always operate and explode on an intended target when authorized by the president and delivered via an appropriate system, because there are things like trajectory sensing switches. That means it has to fall from a plane or something before it will explode, and never otherwise. You could beat up a nuclear weapon. If I had one in front of me, I could hit it with a hammer, or I could try to burn it. What I would accomplish by doing this is either causing a radioactive release or setting the explosives off, and thereby also producing a radioactive release. And while this would not be a fun scenario, in fact, it would be a very large emergency where the federal government got involved, it would be confined to a relatively small area, as opposed to the nightmarish scenario of trying to manage fallout over hundreds of square miles. So, in conclusion, an impressive variety of methods are used to ensure nuclear weapon safeties. PALs, weak links, strong links, the always never concept, security built up around the weapons, and design features informed by high reliability theory that we hope will make the weapon never function as we don't intend. And that incident I spoke about at the beginning, where a nuclear weapon exploded, a missile exploded in a silo and threw the warhead several hundred feet, that actually happened. There was a case in 1980 in Damascus, Arkansas, where a Titan II ICBM exploded, and it tossed the silo lid off, and it tossed the warhead several hundred feet. Now, the warhead did not explode, even though it used far more primitive safety features of yesteryear. There were still safety features, and it didn't go off. But if it had, that would have been a 9 megaton warhead that would have produced just an unimaginable emergency, and probably some sort of massive political fiasco. So, in conclusion, I think we can be pretty confident that there will not be an accidental nuclear explosion, or at least that it's so improbable we can't think about it. But if we ever do see something that looks like the sun rising in the west, well, I can tell you this: the high reliability theorists will have certainly lost their bragging rights. Thank you.